In this video, we're going to be talking about random variables and probability distributions. Specifically in this video, we're going to be talking about the probability distributions for discrete and random variables. Probability distribution is a model that describes the long-run behavior of a variable. In Wolf City, it's a fictional place, regulations prohibit more than 5 dogs or cats per household. So we're going to begin by defining our random variable. So we'll say let x equal the number of dogs and cats in a randomly selected household in Wolf City. Is this variable going to be discrete or continuous? Because it's asking us for the number of dogs and cats in a randomly selected household in Wolf City, we're looking at discrete information. So now we want to know, what are the possible values for x? Well, you could have 0, 1, 2, 3, 4, or 5. Now, the Department of Animal Control has collected data over the course of several years, and they have estimated the long-run probabilities for the values of x. They've determined that the probability of 0 is 0.26, the probability of 1 is 0.31, the probability of 2 is 0.21, the probability of 3 is 0.13, the probability of 4 is 0.06, and the probability of 5 is 0.03. What do you notice about the sum of these probabilities? That's right, it's 1. This is called a discrete probability distribution. It can also be displayed in a histogram with the probability on the vertical axis. So something like this. Let's talk a little bit more about discrete probability distributions. It gives the probabilities associated with each possible x value, and each probability is the long-run relative frequency of occurrence of the corresponding x value when the chance experiment is performed a very large number of times. And third, it's usually displayed in a table, but can be displayed with a histogram or formula. Let's talk a little bit about the properties of discrete probability distributions. First, for every possible x value, the probability of x will be between or equal to 0 and 1. And for all values of x, the sum of those probabilities will equal 1. Let's go back to our dogs and our cats in Wolf City. So again, remember that x is the number of dogs or cats per household in Wolf City. So the question is, what is the probability that a randomly selected household in Wolf City has at most 2 pets? Well, let's take a look at that. What does this mean, at most 2 pets? Well, that means that it could be 0, 1, or 2. So all we need to do is add the properties, or excuse me, the probabilities of 0, 1, and 2, which gives us 0.26 plus 0.31 plus 0.21, which equals 0.78. So the probability that a randomly selected household in Wolf City has at most 2 pets is about 78%. Let's change up our question. What if we ask, what is the probability that a randomly selected household in Wolf City has less than 2 pets? Again, what does this mean? How many pets would we get to include here? So if we're saying the probability of x is less than 2, we're looking strictly at 0 and 1. Notice it does not include the 2. So we'll simply need to add our 0.26 and our 0.31, giving us a probability of a 0.57. Let's change our question one more time. This time we want to know what the probability is that a randomly selected household in Wolf City has more than 1, but no more than 4 pets. So what exactly does this mean? Well, this means that we're looking for the probability that x is between 1 and or equal to 4. So we're looking specifically for the numbers 2, 3, and 4. So we'll add those probabilities together. So we'll add 0.21 plus 0.13 plus 0.06 to get 0.40. Now, when calculating probabilities for discrete random variables, you must pay close attention to whether certain values are included or not included in the calculation, as it will change the results.